So let's say we're asked to solve for x using the combination formula. Again, like we did with our permutation formulas, we're going to expand each of these individually and see exactly what it is that we're looking at. Okay, so when I expand this properly here, I'm going to actually simplify this a little bit further. Just remember that you have to clearly indicate what the x is. Is it the r part of the formula or is it the n? And in this case, since it's NCR, we know that the x is part of the r. So we're going to go 7 factorial over 2 factorial, and then of course this is going to be 5 factorial. And actually I don't need the brackets since I've solved within the brackets. And then this side is going to be 7 factorial over x factorial, and then 7 minus x factorial since we don't know what x is. So one thing to remember here is the multiplication property where a times b is equal to b times a. And what I mean by that is 2 times 3 is the same thing as 3 times 2. And so when we look here that the left side has to equal the right side, well, 7 factorial is present in both of them. Now here, 2 factorial times 5 factorial would be the same as 5 factorial multiplied by 2 factorial. And so if x with that logic was equal to 5, then we would see, and if I rewrite it as follows, we could see using the multiplication property over here that 7 factorial, right? If I just switched 5 factorial and then 7 minus 5, that would equal 2 factorial. That would be the same thing as this. And so using that multiplication property, which is key, I would say in some cases, we can get the same value. So x would have to be then equal to 5. So let's say in this question I want to also solve for x. So in the first equation, or on the left side, x is an n value and r is the 3. And then in this case, same thing, x is the n value and 7 is the r value. So when we expand this, it's going to look like this: x factorial over 3 factorial multiplied by x minus 3 factorial. And then that is going to be equal to x factorial over 7 factorial. And then that would be equal to, or sorry, multiplied by x minus 7 factorial. And so same thing over here, where if I remember the multiplication property of a times b is equal to b times a, then we could kind of simplify it as follows. If I do 3 times 7, then that would be equal to 7 times 3. Now I've chosen numbers 3 and 7 because, well, those are the ones given to me over here. So then I think about, well, what can I put in the first bracket that would get the bracket to equal 7 for the x value? And that could be 10. So if I go 10 factorial equals 3 factorial multiplied by 10 minus 3 factorial, that would be 7 factorial. And then again, the value of 10 applied to the x on the other side, that would give 7 factorial. 10 over here minus 7 would give me 3. And so then I would be able to use that multiplicative property where 3 times 7 is equal to 7 times 3. And so therefore, x is equal to 10, because that's the number I had to plug in order to get these numbers to be the same. So now let's solve for a little bit more of a complicated one over here, where we write n choose 4 over n minus 2 choose 2 is equal to 1. What we're going to do is we're going to expand each of these and then see if we can simplify it. So when I expanded each one here, and I tried to correspond them to the correct colors. So at the top here, I have my NC4 expanded. And then at the bottom, I have my n minus 2 C2 expanded. And one thing to keep in mind is that the entire n minus 2 is equal to the n portion. So I had to make sure to carefully sub that in for the n in that part of the formula. So what that breaks down to is as follows, and I'll just kind of rewrite it here, and then we'll re-expand it. So we got 4 factorial multiplied by n minus 4 factorial, and then divided by, we have n minus 2 factorial over 2 factorial, and then n minus 4 factorial. Now I'm going to split these up into steps. So I can see that I can remove the n minus 4 factorial right away. So we're going to rewrite this, and we'll do the rest of the work over here, as n factorial over 4 factorial. And that's going to be divided by then n minus 2 factorial over 2 factorial. And that's all going to equal to 1. And then we're going to expand this until I have a common denominator with this. And so I followed through with the formula until I had n minus 2. Now we're going to remove them from both the numerator and the denominator and work with what's left. Next, we're going to simplify the 4 factorial and 2 factorial in order to see if there's anything that can cancel out there. And that'll leave us with n times n minus 1 over 12, and that's going to equal to 1. And then we're just going to cross multiply this over here so that we have n squared, and I'm going to expand this as well here. So the n squared minus n is equal to 12. And of course, we can convert that to a quadratic form. N squared minus n minus 12 equals 0. And then we can factor this here or apply the quadratic equation, whichever way you like, in order to obtain the right answer. So I want you to go ahead and try this part out yourself.